Good afternoon. Am I audible and visible to the participants?
Yeah, you are audible to me at least.
Okay. Okay. I got the messages from participants. Great to see you all again. Let me give an introduction of today's webinar now. Today we will have a technical session on simplified detailed vulnerability assessment of lifeline buildings and seismic retrofit strategies by the senior principal scientist and professor Dr. Ajay Chourasia. He is also the group leader of 3D concrete printing and he belongs to the structural engineering group of CSIR. Let me tell you how the session will proceed. We'll have a few words from IS-Structi President, Mr. Alok Bhaumik, and then we will have a session by the Dr. Ajay Chourasia. I'll give a brief background of our speaker. He is a senior principal scientist and group leader of 3D concrete printing at CSRI, as I said. His Ph.D. is from the IIT Roorkee, and his topic was performance evaluation of confined masonry buildings. His interest is in precast buildings, structural health monitoring, experimental investigation of buildings, components, earthquake, design and construction, confined masonry, retrofitting, seismic vulnerability, numerical analysis, historical construction, and quite a varied topics. He has published more than 100 papers in the international and national journals and conferences, more than 75 reports, and some books on earthquake resistance design and construction and similar topics. He has 4 Indian patents in his names, and so far he has guided 3 Ph.D. students and 30 MTech students. He has developed an innovative spinners tool for design of RC slabs and beams for residential buildings, and also prepared a documentary which are very widely referred in the construction sector. And we are very happy to have him today here. But let me first get back to our IS-Structi president and see what he wants to say today. Sir, please.
Good evening, friends. First of all, I would like to thank very much Dr. Anil. I'll be very brief in my presentation and would not stand in the way really between you and the speaker. At the outset, I would just like to congratulate our events committee members of IS-Structi and the team members of our secretariat. They have put up a great effort, and we have been organizing series of webinars. We have already conducted 5 webinars. This is the 6th in the series, and I'm very pleased to tell you that we have 4 more in the pipeline, and there are many people who are willing to sort of participate. I sincerely congratulate our team for making this huge effort. Let me tell you that, under the best of circumstances, it would have been very difficult and challenging task to organize such webinars. And to do this in these difficult circumstances, where most of us are actually locked in our respective houses, this is a tremendous achievement, something which is absolutely spectacular. And therefore, actually, I decided to speak today to express my sincere thanks. A big thank you to the team, particularly Dr. Anil Sheth. I would also like to take this opportunity to thank all the speakers and faculty who are supporting us in this difficult time. Special thanks to Dr. Ajay Chourasia for sparing his valuable time today with us and for sharing his knowledge. Despite many of the, must be pressing engagements with regard to his family, his organizational work, his friends, he has agreed to spend quality time with us and with you, with the engineering fraternity. So we are indeed thankful to him and much appreciate this gesture. Finally, I would also like to thank the participants who are taking keen interest in these kind of webinars and in building their knowledge base. You guys are fulfilling one of our objectives of IS-Structi, that is to disseminate knowledge and we sincerely thank you for this. With these few words, I hand over the stage to Dr. Ajay Chourasia to please deliver his presentation. Thank you.
Thank you, sir.
For this particular webinar. At the outset, I would like to thank Dr. Bhaumik for a nice introduction, as well as to Dr. Seth and Dr. Shilpa Pal of DTU. And it is a pleasant duty. It is basically a pleasant duty for me to deliver a talk on simplified and detailed vulnerability assessment of health, buildings, and seismic retrofitting strategies. As you know, this is a very pertinent topic to the present scenario of the country, or I can say of the world, in which we are passing through. Of course, it is a very critical phase. I wish you and your family a safe stay. But at the same time, we need to understand that it is a great opportunity for us from technical reasons, although the COVID-19 has impacted adversely to the construction industry. And as you all are aware that the construction industry contributes to the tune of 15 to 18% of GDP growth. So it is very clear that if construction in the industry suffers, definitely the national growth will reduce. So it is very pertinent, and it is we all structural engineer family of the country should take a pledge to take this particular move forward, to take this particular country forward in a proactive manner. Now, in this, when structural engineer or civil engineering sector is considered, construction industry is considered, it has been impacted adversely in terms of lockdown, construction work hampering, thereafter the migrating labors, then thereafter the supply chain is disrupted. Important thing is the fear psychosis curve has taken its exponential shape. So under this adverse scenario, we have to find out the way how to take these things forward by technological and innovation to be built. At the same time, conversely, when we look at the hospitals which are primary in need at this point of time, we have found that not only in India but all over the world, the lack of hospital facility has also been felt. This is okay that this is only a pandemic COVID-19 we are passing through. If at all it has come in parallel to any seismic event like earthquakes, then again it will be a paramount shift of hospitals requirement. And in this case, there is their need that whatever the existing hospital facilities are there, they should be functional even after any kind of disaster happen. Normally, in this particular pictures, these are the pictures which are commonly seen after any kind of seismic activity which happens not only in our country but world over. And this is not acceptable, at least for any building, particularly hospital is considered, because we need the hospital to be functional after any kind of a disaster. So it is if we could talk about the performance objective, we want immediate occupancy performance objective for the hospitals or any lifeline buildings, but we cannot compromise for any other buildings as a life safety is as my performance parameters. Before going into detail, we need to understand what are the seismic risk elements involved. So seismic risk can be expressed as a function of hazard, exposure, vulnerability, and location. Hazard is a nature's fury. We cannot control it. We have to live with it. So this is the way of life. Now, when you talk about the exposure here, engineers, structural engineers, and practicing engineers, and all the stakeholders in the building industry has to come forward and work in a cohesive manner. Then only our existing built environment is seismic resilient, hazard resilient. Thereafter, the vulnerability, whatever the is also, which is nothing but the damageability of the exposure under the action of hazard, and the weaker ones being more vulnerable and risky, and then the stronger ones. So that is why we need to take care of the existing building stocks also into mind, and we have to look into whether these existing building stocks are adequately resilient and maintained properly, because even if you have designed the buildings properly, not constructed, again a vulnerability figure increases, and further not maintained properly, again that will increase to a manifold. Apart from the location, that is also very important, because how far the exposure is situated from the hazard location, that is also very important. The nearer ones are more affected than the farther structures, and the local site conditions which can modify the hazard affect the stability of the structure, and such as the topography, soil deposit, whether the soil is liquefiable, water table, all these things has to be considered. So in summary, we need to understand that the seismic risk can be expressed as a function of H, E, V and L. But at the same time, we need to understand what our understanding about the earthquake resistant design is concerned. Whether we are targeting to the repairable or irreparable facilities. So ASC 41 2017, earlier it was FEMA 356, clearly delineate that the performance levels or performance objectives have been categorized in 4 verticals, namely the fully operational, which is mandatory for the important building or lifeline buildings, then operational, life safety, and near collapse or collapse prevention. Inversely, when we consider the earthquake levels or earthquake design levels, then we can categorize them as a frequent, occasional, rare, and very rare earthquakes. So in frequent earthquakes, all my facilities should be functional. So now there is a great challenge to the structural engineers that we have to act proactively and bring back the functionality of all our structures even after any great disasters. And for that purpose, what does it mean? We need to understand when we compare a base shear versus roof displacement, and at that time we can clearly delineate that the structure should be functional under the frequent earthquakes, having low magnitude, and it should not suffer any kind of a damage. Whereas under occasional events, the structure might go under small, minor non-structural damages and minor damages under horizontal lateral load resisting element like beams or diaphragm. Whereas under the major event, the non-structural elements are allowed to fail, but collapse is not permitted. Even the non-structural damages can occur in the structural element on non-structural element, but permanent collapse is not acceptable. At the same time, the structural may go under large deformation, but collapse should be prevented. So basically, we need to understand, with this background, we need to understand what the international CSIR framework says about the disasters risk reduction 2015 for lifeline buildings. So basically, CSIR frameworks 2015 mentions about the strength, promote, and consider. It emphasized that this strengthen the disaster resilient public and private investments, particularly the structural and non-structural members, so that it should be functional. Then promote the resiliency of the new and existing structures. So that is not a that can be very easily done for the new structures. But now the challenge is how to make out the compliance of the first vertical. And last vertical, that is the consider the relocation of the public facilities which are unapproachable. That is also one of the important event. But in this particular presentation, we will be focusing on the vertical one, that is to strengthen the disaster resiliency of the public and private investments, particularly the schools and hospitals. In fact, in this contrary, when we look at the sustainable development goals of the globe, so there also the health facilities and safety has been given prime importance, and in that the concern will be the health facility collapse at the time it is needed, so that is not permitted. If during the event occupant of the building must exit through the showers of non-structural elements, so then the building cannot be described as a safe building. So FEMA clearly says that it is not only the structural element, but my non-structural element should also be taken proper consideration, because normally we have seen after any seismic events, in particularly in hospitals, your structure may be standing perfectly correct, but the non-structural elements, which is in the form of a false ceiling and furnishing items, so they falls down and lost appendages, claddings, they fall down, and as a result, more hazard is resulted out of the failure of the non-structural element. So we need not have to see the building as such in isolation. At the same time, we have to see the non-structural element and the content of the building also when a seismic resilient building is to be designed. So for that purpose, we have to give proper attention to structural members. That is, either it could be a moment resisting frame building, braced frame building, or shear wall or structural wall buildings. But non-structural elements are very well important, because if mass is increased, then again the inertia force will increase. Contrary, when mass is reduced and when it is not holded properly, then collapse is likely to occur. So we have to make out a balance between the two and do the proper anchorage of non-structural element to the structural element, so that safe exit is possible for the occupant. In that perspective, when you see there are a wide range of codes which are available in our country, and which has been expanded day by day and upgraded day by day, time to time, by the BIS and NDMA. But as regards to the strengthening or retrofitting is concerned, recently a push forward has been taken. When we consider the developed country, there is a standard framework guidelines prescribed for existing buildings for their seismic vulnerability assessment, then seismic evaluation, retrofitting strategies, and retrofitting quality assurance. And there is a holistic approach they are giving, whereas in our country recently that activity has also been taken up. And when you talk about the seismic vulnerability assessment is concerned, there are two codes, that is IS 13935, which clearly mentions the repair and seismic strengthening of buildings, and the code IS 1598-2013, which talks about the seismic evaluation and strengthening of existing reinforced concrete building is concerned. Whereas the seismic vulnerability assessment, recently the action has been taken by NDMA, and a code will be brought out on how to carry out the seismic vulnerability assessment of existing building stocks. I will come to that just 2-3 slides later. But in between, the basic objective of this particular work is on the seismic simplified and detailed vulnerability assessment, which is a second and third vertical, or second or third steps, then the rapid visual survey. So in this, basically there are 4 activities need to be done to carry out the simplified vulnerability assessment of existing facility, then to carry out the detailed vulnerability assessment, and then suggest the retrofit measures. And whatever the retrofit measures you suggest, you have to take a proper judgment, so that the recommended measures should be easily implemented, technology is available, appropriate skill is available, and cost economics should also be taken into account. In no case the reconstruction cost should be more, the retrofitting cost should not be more than 50% than that of the reconstruction cost. So according to that, the engineer has to decide based on the basic seismic evaluation to be made. So let us focus on what kind of seismic evaluation need to be done, and what are the basic important parameters required for conducting a systematic seismic evaluation of the existing building stocks. So for that purpose, when you talk about the seismic vulnerability, the structural system, and it can be divided into 2 again, the structural and non-structural element. In the structural element, we have to see the typology, history of the building, and the architectural shape, plan dimension, and design and execution, and appropriately suggest the retrofit measures which are executable and implemented by keeping in the techno-economical aspect into consideration. And similarly, non-structural elements should not be overlooked. So they should also be given proper attention, At the same time, the equipment, heavy mass in the form of a water tanks and other things, and the services like HVAC, gas pipeline, and other things which are commonly available in the hospital, they should also be given proper impetus. When we are talking about the vulnerability, so vulnerability of the building in the building introduced at different levels or different stages. First, vulnerability can be introduced at the time of design stage. In the design stage, there could be a deficient design, errors in the design, or changes in the standards, because the standards are getting upgraded day by day because of increase in the knowledge due to the continuous R&D going on across the country and the globe. And the poor architectural shape. So today, if you are designing some building, suppose, so it may be vulnerable 10 years down the line because it may not comply the standards requirement which are there at that point of time. So at this point of time, we should ensure that whatever the building we design, that should comply the today's standard provision. So if we overlook, most of the times it has been noticed that the people are little bit taking a shortcuts. They are not consulting the structural engineers and go on constructing the building the way they are looking the issues. But this is not done. Second level of, even if the structural engineer designs the structures properly within the four walls, but implementation will be an issue, and there are different kind of problems which come across. The defective or poor detailing means whatever the detailing structural engineer has done, that has not been implemented properly. Poor construction because of the various reasons, the poor maintenance, and existing defects, that is the corrosion, settlement of foundation. These are the aging and addition and alterations. That is also these are also reasons which are causing the vulnerability in the structures during the construction as well as during the operational stage. So hence there is a need that we should generate an awareness among the society that consultation of structural engineer is a prime important, because when a competent structural engineer look at this particular issues, he will go through all kinds of basket of Indian standards, and in our country, one IS 1893, 13920, 193. So there are several codes which are in existence and which are being adopted by all the structural engineers very judiciously, but might be overlooked by some of the non-professional people approach. At the same time, we have to, as a structural engineer, whenever we design the building, we should not only look into the aspects of the recommendations made by the BIS. At the same time, NDMA hospital safety guidelines, that is over and above additional recommendations, has been portrayed in therein, and the NDMA has also brought out the retrofitting guidelines. So these guidelines may take certain times to become Indian standards, but it is a good approach that the structural engineers fraternity should look into all these aspects, and at the time of design of any hospital or Lifeline building. In fact, for that purpose, additional reference can be made to ASC 41 2017, in which all these performance aspects are given very category in detail. I will focus all this aspect in subsequent slides. When you talk about the codal recommendations, as I mentioned, NDMA has come out with the safety guidelines, and these guidelines should be referred systematically, and wherein categorically mentioned that all the hospitals should be designed for the immediate occupancy, for the critical units, and other units might be of less importance, can be designed for the less seismic, for the life safety. So when you are talking about the seismic vulnerability assessment, it can be divided into three levels: level 1, 2, and 3, namely the rapid visual screening, simplified vulnerability assessment, and detailed vulnerability assessment. So rapid visual screening, the name itself suggests it is random sampling is made, and so I'm not going into detail because this can be done after proper training. But a very good news is that NDMA has again taken a very proactive step in defining a unified, simplified pre and post rapid earthquake safety assessment format for different type of building typologies, that is RCC, load bearing structures, confined masonry, stone buildings, mud houses, dachi diwari, even ikra houses. So these are, and that is pre. A stands for pre and B stands for post. So these are the standard format which is under the final stage and which will be brought out. So that will be a unified approach will be adopted across the country for assessing the rapid visual survey. Now I will be focusing more on the simplified vulnerability assessment. So this kind of assessment basically has been driven in following steps. In this, what we need to do is we have to go beyond the RDS and we have to do proper site survey and few investigation at the site and do the proper analysis at office. And for that purpose, when we are saying the steps involved in the SVA is condition assessment of the site, then prepare the as-built drawing, because most of the there are deviation from the from the drawings which has been considered for the construction purpose, and after this the construction is completed. So it is better that we should compare both the drawings properly. Then material strength parameters need to be understood from the code as well as from the structural details and from the site observations. In this simplified vulnerability assessment, there is no, we are not focusing much on understanding the material properties at this point of time, in situ material properties of the either the reinforcement or the concrete or the masonry if it is a load bearing structure. Then based on the data given in the drawings, based on the visual observations, as-built drawing, generate the model of on the as-built drawings with the respective loading, then the configuration, and then carry out the different kind of analysis, primarily the linear static analysis or non-linear dynamic analysis or linear dynamic analysis, depending upon the structural systems, and carry out different checks. Mainly the checks considers the configuration related check, geometrical checks, and strength related checks. In the strength related check, we need to focus on the shear stress, axial stress, and drift and deformability. Interstory drift is more important. So let us have a look on the quickly on the SVA, that is the simplified seismic vulnerability. In this, basically we need to do the condition assessment survey, thereafter prepare the as-built drawing, and the drawing should be done properly in the plan elevation, properly demarcating all the connections details. Then whatever the distress, what we do, so proper distress mapping need to be done so that this can be incorporated while doing the analysis. This is the standard format we normally use to capture the information from the site, which is which comprised of the general information, then general data about the building, architectural data, then non-structural data, then equipment and the content, and some which includes the content as well as the like additional of water tanks and other things, additional loading. In fact, hoardings and other things should also, most of the times which are mounted on the buildings, that should also be taken into account. So, consequent upon completion of these activities at site, then you need to carry out the three-dimensional analysis. For this purpose, the modeling can be done either in for the masonry by using the shell elements, by taking 2D element. There are various softwares available. Material properties should be taken either from the drawing or from the site investigation. The geometrical dimensions as per the as required or as per the measurement at the site. Similarly, structural members such as beams, slabs, and columns, that has to be modeled as a 1D element, 2D element, and the data from the site can be taken. The loading can be taken appropriately from the respective codes as it is mentioned herein. So these loads will be dead load, live load, snow load if applicable, then seismic load, and combination thereof as it is delineated in IS 1890-2016 has to be considered. Upon conducting, so this is the case of a load bearing structures. So once you do the modeling properly, including so subsequently you can carry out the it's in case of a masonry building, you need to carry out a non-linear response spectrum analysis or a response spectrum analysis, and in which you need to carry out the configuration related checks, which in terms of table 5 of IS 1893-2016, that is a torsional irregularity, re-entrant corners, floor slab with the excessive cutouts, out of plane and non-parallel walls checks. Similarly, the provisions given in table 6 of 1893 has also been should be checked in terms of stiffness irregularity, mass irregularity, vertical geometry irregularity, then discontinuities and strength irregularity checks. And these checks, when you carry out, this should be cross-checked by your manual calculations, and then you have to carry out the checks for the column width. So whatever the provisions given in IS 13920 about the sizing of column, beam, ductile detailing, if it is possible to verify at the site, that is fantastic. If you have the details in the drawings that need to be verified at the site, and according to that, these issues should also be verified based on your analysis. So mostly the strength related checks includes the shear stress checks, then axial stress deficiency, appropriate column shear stress, then drift, and the deficiency in this column. So in short, you have to carry out the check the efficacy at the global level and the elemental level. Then in this case, after doing so, you have to identify the deficient members, and only the deficient members can be considered for the retrofitting, and reanalysis is required. After doing the reanalysis, you have to re-ensure that whether you are coming into the compliance of all the criteria, whatever has been discussed. But primarily, when you are the simplified vulnerability assessment generally being done when you are when your structure is passing, then there is no need of going to the detailed vulnerability assessment. But if your structure is not complying to the present codal provision, then there is a essentially need to go for a detailed vulnerability assessment. So what is the methodology to be adopted for detailed visual vulnerability assessment for masonry buildings is normally once you arrive at the building is deficient, then you need to incorporate the appropriate retrofitting measure to the deficient members. So then it is again a judgment of a structural engineer based on the technological options available at that particular site, skills available, and the problems which are posed to you, and based on that perform the linear dynamic analysis if it is a masonry building, and non-linear dynamic analysis if it is a RCC frame building. And after that, you have to carry out all these usual checks, whatever I have discussed, and ensure that all the element structure as a whole, global level as well as the element level, the structure is complying to the provisions which has been laid down at different sections of the code. So this is the same. On the contrary, when you look at the RCC frame building, in this you have to perform the linear dynamic analysis. Apart from that, after retrofitting is done, you need to do the non-linear time history analysis as well. So in the detailed vulnerability assessment, the requirement is, again, you have to do systematic, detailed, non-destructive tests to understand the material properties, in situ material properties of RCC, steel and masonry, and take the appropriate figures, and with all those facts and figures, you have to put that thing and update your model, and then carry out the detailed analysis. If you have certain issues on the foundation level, you need to do certain trial pits, and if required, certain soil investigation also. Then decide the performance objective. In case of hospital buildings, it is immediate occupancy. In case of residential building, it may be a life safety. Then the process of modeling and other coding of various criteria is, as usual, you have to do. Then whenever you are dealing with the masonry building, it is generally the masonry strength is ignored. So it is very good that we should conduct certain masonry tests mainly the flat jack test, which gives you the in situ masonry strength, and whatever the in situ strength you get, that can be incorporated in your model. But nowadays, recent IS 1893/2002 also allows you to take out certain units and mortar, get their strength values, and based on the formulations given therein, you can estimate the whatever the masonry strength is can be calculated, and that can be incorporated in the model. Alternatively, the codal provisions as given in the IS 1905 can be adopted for as a permissible stress or strength checks. So usually the steps which are being followed for the non-destructive test and detailing is represented in this particular drawing. So whatever the entity you carry out, it should be marked properly on the drawings, so as it is shown in this. And along with that, you need to highlight those things in the scheduling as well. Most of the times foundations are ignored. You need to give proper attention to the foundation, carry out certain trial bits, detail it properly on the drawings. In case of RCC buildings, you need to do the non-destructive test. For that purpose, there are different tests. Rebound hammer test, which is a very qualitative one, whereas the concrete core cutting, that is a quantitative and which is a more reliable, and that input or that resultant can be incorporated in the model. So believe on the data which you get based on the concrete core cutting test. In addition to that, these are the other tests, which are the ultrasonic pulse velocity, rebar locators. So this is the rebar locator test is also very important to reassure the whatever the detailing has been given in the drawing has been implemented in by execution. So after conducting the non-destructive test, it is a very smart approach that the locations of the test location should be marked very carefully, systematically. Based on the SV analysis, you have identified certain elements which are vulnerable. So you do not forget to carry out analysis, carry out the non-destructive test at such deficient members to get a deeper insight about the structural in situ material properties. So this is the view of the flat jack test, which normally being conducted for getting the information about the masonry strength, whereas this is the concrete core test, which is usually applied on the RCC frame to get the information about the RCC structural elements in the building. So this is one of the pictures which shows the investigation on the soil investigation and existing foundations by conducting the trial bits. Then the different tests are based on the different tests. You can delineate the deficient members and decide the appropriate retrofitting strategy. There are various retrofitting strategies which are available separately for the masonry buildings and for the RCC buildings. So widely used retrofitting options for the masonry buildings comprised of the traditional split and bandage technique, in which the steel or welded wire mesh is provided in the form of a stitching, particularly at the sill level, lintel level, at the corners, and around the openings. Alternatively, the same split and bandage technique can be applied, only the material variation is there. So instead of concrete and steel mesh, FRP is also being used widely. But important thing is that all the retrofitting measures, whatever you are implementing, that should be executed properly, in which the preparation of the surface and other aspects and proportioning of the material is very important. So that's why it is my humble suggestion that whenever you are selecting any contractor or any executing agency, he should be competent in executing the job. This is a specialized item, so that's why we have to be very professional while conducting the retrofit measures. Alternatively, another vertical is on the sandwich, when you are getting very inadequate lateral load resistance from the wall, and when there is a need for increase the sectional or section and enlargement. At that time, sandwiching the entire wall by means of providing additional reinforcement with concrete, maybe preferably the shortcut limited to 50 mm thick with high grade, high strength concrete is applied. Another approach is by sandwiching the hard drawn wide mesh. This has to be provided on either side of the walls, and it is adequately connected, and the connection should be by means of a bolt. If you are connecting by means of a nails, that is not a good practice. Instead, you should use the staples, which is double-ended, and whenever you are using staples, you should take into account that it should be provided in a staggered fashion, not the way it is shown in this particular photograph, and the stapler density should be minimum 9 staplers per square meter should be ensured, so that the good connection between the additional reinforcement and the existing wall is achieved. And then you need to understand that you need to ensure that the connection or bonding between the existing element and the new element, new concrete, has to be assured. For that purpose, you need to provide the additional bond code and bonding agent before application of any shortcut element. So these are the normal checks which we need to adopt in terms of compression, tension, bending, shear. So this is very much delineated in IS 1905 1987, and also in the IS 14926 provision has to be adopted when you are dealing with the masonry buildings. So when you look at the grade of the mortar, so you can refer the table 1 of IS 1905, which delineates, depending upon the mortar grade, it gives you the different minimum compressive strength of the mortar. This is one of the approach in case you are not adopting proper site investigation, but for that purpose you need to understand the mixed proportioning of the mortar. So appropriately you have to select the category of the mortar. Apart from that, to understand the masonry compressive strength, table 8 of IS 1905 can be referred, which gives you for the different mortar type and different unit strength, masonry strength can be obtained. As an alternative to this IS 1905 provisions, recently in IS 1893/2016, a very simplified approach has been given, in which you can calculate the modulus of elasticity E for the masonry and masonry strength indirectly by a very simple test, in which you need to take out certain samples of the units and the mortar, and based on the which can be very easily done, and based on that you have to just input that in this particular formula, get these values, put in your model, and carry out your further analysis. So this is very much adopted in the while dealing with the masonry buildings analysis. Then usual factors as the stress reduction factors, area reduction factors, then shape modification factor can be can be obtained from IS 1905, and alternative retrofitting measures, as I suggested, can be conducted for the masonry buildings. Whereas when you are dealing with the RCC building, when you are dealing with the masonry buildings, so whatever the design you carry out, retrofit strategy you carry out, so that should be again adopted in your model. Check and cross-check whether all the permissible stresses in terms of compression, tension, shear, bending are within the permissible limit as provided in the different codes, and then only the retrofitting measures can be detailed in the drawings properly, so that this is a very quick look I am showing how to strengthen the corners of the two perpendicular walls, how to do the stitching. So whatever the retrofitting strategy designer has perceived on the desktop, that should be brought in on a drawing sheet properly, and so that the message will be clearly conveyed to the retrofitting engineer who is conducting or executing agency, who is doing its job at the site. But based on that, this is one of the so based on this, I have highlighted for the masonry buildings. When you are looking into the RCC buildings, so in this case you have to follow, these are the steps. So DBE levels of earthquake shall be considered for linear dynamic response spectrum analysis. Then procedure adopted for the scaling in the recorded time history analysis is acceptable. So in this, you have to carry out the time history analysis as well when you are dealing with the hospital buildings. So these are the steps you have to consider, and then carry out the three-dimensional modeling. You can use any software, ETABS, SAP, STAD, and whenever you are modeling the model, you have to ensure that whatever the deviations, addition, alterations are there, that should be incorporated. So you should carry out the modeling on as-built state, incorporating the NDT results into the members as a material properties input. Geometrical property will be governed by these as-built conditions, and then after which you have to carry out, identify the deficient members, and once the deficient members are identified, as well as means two checks at the global checks, total drift, lateral strength, as well as at the element level, you need to carry out the checks, and then appropriately decide which retrofitting options you have to go for. So for dealing with the RCC frame building, there are various alternative options for retrofitting. So these are jacketing using concrete and additional reinforcements. So section enlargement is one of the approach, but only thing is the section sizes increases exceptionally large. Alternatively, the FRP jacketing can also be applied, but at the same time, we need to understand the pros and cons of any of the retrofitting strategy which we are adopting. Third option can be available is for jacketing using steel plates. So the appropriate strategy can be selected based on the site conditions, technology available, skill and expertise available at the site, and important thing is the facility given for the retrofitting. Means whatever the building is there, how much time is owner it is being giving it to the retrofitting agency for retrofitting. So that based on all these criteria, one has to decide which retrofitting options has to go. At the same time, we have to see what are the cost implications. So as I mentioned earlier, that each element at the global level as well as at element level, we need to verify the capacity and what is the demand which are posed by the any kind of event. So based on that, we need to carry out the demand capacity ratio for each element, for each joint, and wherever we are getting the DCR less than 1, that shows the demand is more than the capacity. In that case, we have to only retrofit those elements, do the reanalysis, and then verify what are the next other elements which are vulnerable. So in that, so the advantage of carrying out the detailed vulnerability assessment is that optimum retrofitting you can do. Instead of jacketing all the column or strengthening all the columns, you can judiciously decide which are the vulnerable element which need to be done, which need to be retrofitted at different levels, so that the performance objective is brought as it was envisaged in the code as well as by the functional use of the building. So this is the flow sheet or methodology generally we follow for the vulnerability assessment for RCC building. So in this, you have to carry out identify the geometrical and material properties, identify and list all the members geometry, then perform the linear dynamic response spectrum analysis as per the code, then identify the deficient members, then incorporate the retrofitting strategy, whatever you are perceiving, and retrofit that particular element and do the reanalyze the building, and then again perform linear dynamic response spectrum analysis as per the codal provisions. And once it is done, the scale the identified 3 recorded time history. So we are expected to do the non-linear dynamic analysis as well. So whenever you are conducting with the non-linear time history domain analysis, you should be very very particular in selection of the time history which you are incorporating. Normally people are so for that purpose the site conditions at your particular site need to be understood properly, and based on that site conditions you have to select appropriate time histories. So different time histories are available at the USGS site. You can take appropriate site time histories and incorporate in the model. Whenever a code suggests that minimum 11 time histories need to be taken, but you have to, again, you can make a judgment whether you have to take 11 time histories or 3 to 4 time histories, but minimum 3 time histories we should take and analyze reanalyze your building when you are dealing with the hospital building as such or lifeline buildings. While doing so, you need to take a very appropriate value for the hinges, for P, M2, M3, and for the columns, and M3 for the beams. So for that purpose, very nice reference can be made to the ASC 41 2017, in which the table 10.7 gives you in the detail the appropriate values to be incorporated for these parameters for the columns and the beams. So these are the typical time histories which can be adopted for the Indian conditions: Chamoli earthquake having a 0.35 G peak acceleration, Dharmshala, then Uttarkashi. Now recently the Nepal earthquake also can be adopted because of the very close and similar geometrical and ground characteristics. So these are the these are the steps which we normally adopt in non-linear while doing the non-linear time history analysis of the building. So in which the spectral axial SA by T curves has to be referred, then this graph to be converted to the time history using frequency domain method, then IS 1893 time history reconverted into the response spectrum for comparison with the recorded time histories. One by one, each recorded time history is to be compared with the target response spectrum and obtain the above steps. So, and the important thing what you need to do is each response spectrum graph is to be scaled so that the criteria of all ordinates being above in period ranging from 0.2 T to 1.5 T. That is, T is the fundamental period of the building what we are envisaging is to be selected, and finally the scale factor to be multiplied with the respective recorded time history to obtain this scaled time history for performing the nonlinear analysis. So these are the important steps we need to adopt it. So and generate the graph which shows the response spectrum scaled using SRSS and IS 1893 target spectrum. Upon completing all this detailed analysis, now it is a job of a structural engineer to transfer its strategy in for the field implementation into the drawings, so that it should be detailed properly, so that it will be implemented properly at the site. But at the same time, I would like to mention here that whatever the strategy you suggest or recommend, that should be feasible, implementable, and executable based on the prevalent practice which is being adopted in that particular region. At the same time, you have to see the cost economics. At the same time, you have to see how much time window you are providing for the retrofitting work to be undertaken. Again, so this was very good for the for the structural members for the masonry and RCC frame building. At the same time, for both the buildings, non-structural items cannot be overlooked. So for that purpose, a reference can be made for the NDMA guidelines on hospital safety, which clearly delineate the approach to be adopted for evaluation of anchorage of non-structural members to the structural members. So these are the sections 5.5.4 can be referred in that particular guideline for designing the connections between the non-structural member to the structural members. apart from that, once these activities are done, again, the structural member, a non-structural member should also be properly anchored so that any kind of a sliding or overturning in case of any seismic activity should not happen. Most of the time, it was noticed that when along the corridor, lot of almirahs are stored or some equipments are placed there, and when occupant is trying to escape, they are getting overturned and there is no room for escape. So that should not happen. So these are the minor detailing, but need to be given more focus. And for that purpose, and whatever the detailing you design, that should be again brought on the drawings for even the non-structural members properly. And that's how there is a need to bring to reduce the gap between the executing part and the structural engineers. So we need to work in a cohesive manner with the practicing engineers as well as the implementing agency, so that whatever the design which has been conducted by the structural engineer in his office is implemented properly. Then only the purpose of retrofitting is served. So nowadays the retrofitting should be taken as an option, as a profession, and I will request all of you adopt this particular profession and let us take this particular discipline forward, because there is a huge requirement in this particular country, because large amount of existing building stocks are vulnerable and they need to be retrofitted, because now we cannot demolish all the things and construct in the new fashion, because sustainability will be also need to be addressed. So it's a good opportunity. In fact, COVID-19 is there, but take this particular opportunity to strengthen in a better fashion. Let us prioritize it. Lifeline building to be taken first on retrofit scale, thereafter other buildings. So with this, I will close my discussions and have a stay safe to you and your family. Thank you so much for your patience, Amy. Thank you.
Thank you very much, sir. And it was indeed, you have covered a lot about the significance of such a vulnerability assessment in this COVID situation. You have also given an idea of various codes and guidelines that address this kind of research and analysis, and the modeling and the assessment framework that should be used for RCC, for masonry buildings. And various retrofitting measures were mentioned with the technologies, and quite interesting to note, and with lot of detailed drawings. And you also touched upon the feasibility and practical aspects of the structures that we need to look at in deciding whether to retrofit or go for reconstruction. And yes, you are right, non-structural cannot be overlooked, and therefore a gap reduction, as you have suggested, among professionals is so important. And it is very interesting indeed. I found, and I'm sure most participants found it very useful. Sir, we will take few questions from the participants now, and I will go in the last order that it has come. Dr. Manmohan Kargal is suggesting that sometimes envisaged interventions are not possible since it would be running hospital. So, sir, can you throw some light how we can handle these challenges?
Yeah, when you have to do a retrofit, that's what I was trying to mention in my presentation also. You have to decide very judiciously how much time window you are providing for the retrofitting activity. And based on the time window, based on the technological skills available, you have to select the appropriate retrofitting strategy. Suppose, as mentioned by Dr. Kalgal, in a hospital building where you have a very limited time window, when I am suggesting, suppose, a shotcrete or RC jacketing, definitely it will hamper the functional things. So in this case, FRP or steel jacketing will be the right approach. So you have to take a balance and proper judgment between the two, and then decide properly. And if at all, but important thing to note, in the operational hospital, if you are carrying out the retrofitting, which is impossible task, because whenever such kind of activity happens, the patients and other facility functional requirement cannot be executed properly. So it is better to make a makeshift arrangement, isolate that particular region, like what normally you see in the airports and other things, barricade the things, take in a piecemeal, complete that particular activity, and then barricade the other activities and carry forward. But this is actually execution, but strategy should also be like that. So, but in such cases, it is good practice that we can make use of a grouting or FRP jacketing. This is, I'm just giving a prescriptive, but whatever the measures I have given, it is not prescriptive, but you have to design it. Whatever the measure you suggest, the procedure I have highlighted is the quantitative procedure. You have to design everything and then do it properly. Till 2005 or so, most of our Indian standards were on the prescriptive basis as far as the retrofitting was concerned. But nowadays, a flare has been shifted from the prescriptive to the quantitative. So this quantitative approach, which has been clearly mentioned in 2013 code, so that should be adopted and carry forward.
I see. Thank you very much, sir. Mr. Sanjay is asking if any retrofitting measures for composite structures, if the strength is deficient, can be suggested.
Can you please repeat the question? Is that present structure is a composite structure?
Composite structure. His question is, any retrofitting measures for composite structures if found strength deficient? Can you have some feedback on that?
Yeah. For the composite structure, if you consider your RCC column is also a composite. Yes. It is comprised of concrete and the reinforcement. Instead of that, what alternatively you can have a concrete column with the RS joist or some combination appropriately based on the site requirement. So you, if you refer the IS 15988, that clearly gives approach, a methodology to deal with this kind of miss. You have to first of all take the detailed geometry and material properties of the composite element, find out its capacity, prevalent capacity based on this material composition, geometrical dimension, material properties, and based on that you can carry out the methodology adopted in the 15988 for retrofitting options. So that again, for that purpose, you need to decide how much demand you are targeting, and for that purpose, you have to meet out the demand capacity less than 1 ratio.
Yes. Another one. Mr. Nikunj Binani is asking that, is there any special consideration for historical structures?
Very nice question. Very good. I was about to mention, but intentionally I restricted myself. Unfortunately, there is no guideline or provision for historical structure in our country nor in Asia. We are totally depending upon the European guidelines. Historical retrofitting in a historical building is a great challenge, because they are retrofitting. You cannot go with the jacketing, or because architectural value has to be retained. So you have to take a very systematic approach to retain, to retrofit this kind of elements, so that the originality cannot be sacrificed at any cost. But when the structures are vulnerable, so that is simple. If most of the historical structures are masonry buildings, for this purpose, whatever the remedial measures I have suggested, they need to be, one of them can be selected and adopted. For I will cite an example. You have a very thick wall, and with the arches, suppose the arch is getting a crack at the crown. So what we have to do? We have to just remove we have to apply certain engineering mechanics approach into it. Whenever the cracks is there, that is because of retention. Masonry is poor in tension, and for that purpose, we need to remove certain bricks from there. When or any units, if some architecture facade is there, remove it properly, mark it properly. Then after that, on the remote, you provide certain element like mild steel. Don't use HYSD steel because again it is more likely to susceptible, or copper. Appropriate steel you can use for restricting the crack, and then you can put the lime Roorkee or some appropriate material, and then you're cladding whatever architecture. So that as a result, what will happen, you have done your retrofitting. At the same time, you have not compromised much with the damage the architecture feature. So retention of the architectural feature is a prime importance, and for that purpose you have to decide what exactly their defect is. Based on the defect, go to the root cause of the defect, and then decide the appropriate strategy and retrofit.
Okay, sir.
But if I will say that RCC jacketing or these things are not advisable when you are dealing with the historical building, but you have to go to the core thickness and then do retrofitting there, strengthening there, and then complete the finishing.
Right, sir. We will take, I think there are many interesting questions, but we'll take 2 or 3 and the rest I will forward to you by email. One question is, there are 2 parts of this question by Mr. Arup Gatak. His understanding is that the contribution of masonry infill walls to the mode shapes is not taken into account in seismic design as per current Indian codes. He wants to confirm if this is true.
Yeah, he's right. Presently, we are analyzing code suggests that you analyze a bare frame and do your analysis. Contribution of infills are neglected, but as a smart engineer, you can account for, and for that purpose, you have to provide adequate link between the two, and you can perform. Definitely, by doing so, your computational cost will increase. Your model will be little bit complicated, but you will be closer to the realistic things. Yes, it is right. Code is not at the moment considering this, but now the code is under revision. 2020 code IS 1893 will take all this infill also into account. So there is an option, and it is being made mandatory that infills should also be taken. So far, yes, we are not considering. In future, we have to.
Right. So with this in mind,
only it will be slightly only thing is, once these infills will be considered in the analysis process, we will be having a very accurate result, realistic results, but computationally it will be slightly expensive, and which we have to sacrifice. But that is not a great challenge basically to the structural engineer.
Right. So then his second part is that if he considers the same, would we gain any advantage by connecting the masonry infill walls integrally to the RCC elements by means of dowel bars or reinforcement bars in case the building has been designed for bare RCC frame? So is there any advantage of connection?
Definitely advantage in terms of stiffness. You will get strength and stiffness also. Definitely you will get a large variations. But only thing is, while doing so, one again important thing you have to see, it should not be a low strength masonry. Means like AAC blocks, if you are using, which is having very low compressive strength. So in that case, you will not get a much advantage. But definitely, if you are again taking some concrete blocks or even the burnt solid clay break units as an infill, so abnormal means exceptionally large amount of stiffness that will be contributed to the frame by infills. So the designs will be more economical in that case.
Right. I think this is the second last question by Mr. Nandadulal Das Gupta. He is saying, Professor, what are the parameters to decide that the structural element damaged by earthquake can be retrofitted or reconstructed? I think you mentioned cost. Is there other?
No. What exactly he is?
What are the parameters to decide?
So
yeah.
So basically, in this now the question is basically focused on the damaged element. So the damaged element, you have to find out what is the demand which is likely to occur in case of next event occur after retrofitting. So for that purpose, you need to understand first of all the demand. Then based on that, what is the prevalent capacity? Suppose in the damage thing, you may consider the capacity as a 0 also. And then for the given demand, you can decide how to strengthen it. And apart from that, different parameter which needs to consider, I said, what is the in situ geometry, material properties, what is the structural type, what is the time window you have, and how the overall quality of construction it is available, and cost. These need to be first of all understood, and appropriate retrofitting measures need to be given. And important thing, what again I'm time and again I'm mentioning, that what is the basically practice, and whatever the retrofitting measure you recommend, it should be done only by the competent engineer, because you have recommended one particular strategy. Basically, duty lies with the implementing agency. If he doesn't prepare the surface properly, if he doesn't do the grouting properly, if he doesn't mix the composition of the different additives properly, so there is no, it makes no sense wasting our money in retrofitting. So quality assurance of the retrofit at the time of retrofitting is also very important. So while selection of the contractor, you have to be very careful in those aspects.
So this is the last question that I am taking on the webinar. Others maybe you can address by email. This is by Mr. Prayas Jain. It is a little long and it has 2 parts or 3 parts of it. One is, if a structure is damaged by an earthquake, stiffness K and damping C parameters of some floors are reduced by 0.7 or 0.8. How can I say that I retrofitted this structure to resist against a future earthquake?
Your damping value reduces.
Yeah, he is suggesting that once there is an earthquake, the K and damping value of some floors are reduced by 0.7 or 0.8. So then how will he be able to say that he has retrofitted this structure to resist a future earthquake?
Yeah, very good question. Actually, in this, when you see the any floor retrofitting is one thing. Basically, you have to see, once the structure has passed through certain kind of earthquake motions, then you need to understand, first of all, by doing detailed analysis, what is the in situ strength, and then retrofitting. Do the appropriate retrofitting measures to bring to the code level criteria. But before recommending the code level criteria, it is good practice that you redo the analysis, incorporating the whatever the design strategy you have foresee, and then verify your damping values at different locations. If it is meeting your requirement, then only you recommend. But it is a good practice that you first of all ensure all these parameters beforehand before recommending.
Right, sir. There is a second part. What should change between the damaged and the retrofitted responses of the structure?
What should change?
Yeah.
If the structure is damaged, definitely your 4 virtues of earthquake engineering is strength, stiffness, ductility, and energy dissipation capacity. So once the structure is damaged, definitely this energy dissipation capacity will reduce, and strength will also reduce, and stiffness, all these parameters will be reduced. So basically you need to increase, you have to give adequate strength as well as ductility. Means in case of future earthquake, means during the after the retrofitting, adequate strength should be achieved and deformability should be there. So this strength and deformability are the 2 parameters which has to be looked into, not only at the element level but at the global level. How you will look it at the global level? By in terms of a interstory drift, which should be less than the code specified criteria, that is 0.4% of story height. So this has to be seen from that perspective.
And then the third part of his question, that is the last one, is what are the parameters that the retrofitting should affect? So I believe these 4 virtues should be affected.
For basically these 4 virtues, after retrofitting, you should have adequate strength. I'm not saying excessive strength, adequate strength, because adequate strength, stiffness, ductility, and energy dissipation capacity. So energy dissipation capacity you may not be able to find out, but all these 3 virtues you should try to increase, then, and it should be made beyond the code specified criteria. Then only you will say, yes, my retrofitting strategy is fair enough, and this particular structure has been brought to that particular level.
Right, sir. So I think there are a lot more questions which I will note down and forward, and maybe we can have another time to discuss that, or maybe by email. I think we should end the session here, and I really thank you very much, sir, for taking this opportunity very positively and sharing so much good knowledge with us. Thank you very much, sir.
Thank you so much. Thank you everybody for joining. Thank you so much.
Thank you. So I'm going off air, and the session is closed.